So these laws of indices, here they are, 6 laws of indices. It turns out that actually the only 2 that are really need deriving in a sense and understanding where they're coming from are the first 2, 1 and 2. They're the basic laws of indices. The other 4, 3, 4, 5 and 6 all come from the first 2, as we'll see. And they're useful in algebra for simplifying things. So we'll look at some examples. Here's one where we'll simplify expressions where we've got powers. So the laws of indices are to do with powers. And then eventually we'll find out that we can then think of those powers in terms of logarithms and come up with the laws of logarithms, which are again to do with powers. So they're all related to each other. So let's look back at these laws of indices again and take them one at a time and see where they come from. So the first one, a to the n times a to the n equals a to the m plus n. That's the first law of indices. The first thing to recognize is that this a to the m, they're numbers, of course. In algebra, all the symbols and letters that we use represent numbers. So these are numbers. This is the base number. So it's a base. We call that the base number raised to a power or an index. So index, that's where the laws of indices comes from, but you're probably more used to thinking of that as a power. So a raised to the power m might be how we'd say that. For example, 3 raised to the power 4 is an example of that. So 3 is the base number, 4 is the power. What does that mean? Hopefully you know that that means this equals 3 times 3 times 3 times 3. So what does 3 to the power 4 mean? It means 3 multiplied by itself 4 times. It's a shorthand way of writing that. If we look at this law of indices here, it's implied that that base number in the rule, and it's the same for all of these laws of indices, must be the same for this to work. We don't know what A is, but whatever A is, it's the same there as it is there. And if we go back to the laws of indices in the first place, look, they're all A. So the implication is that these laws of indices only work if the base is the same. When I combine them together. Well, in fact, we're talking about these 2 really, because the others, it's only the same one anyway. So let's go back and see what implication this has. So if I take my example, 3 to the 4, and multiply that by 3 squared, for example, then that actually, if you think about it, 3 to the 4 is 3 times 3 times 3 times 3 times 3 times 3. There's the 3 to the power 4. There's the 3 squared. So that's actually 3 multiplied by itself 6 times. So the law of indices is saying if the base is the same, I add the powers. 4 plus 2 is 3 to the 6. And we can see that there, why it works. That's all this first law of indices is saying. If the base is the same, and I multiply them together, I add the powers. That's what the first law of indices is saying. But it only works if the base is the same. Similarly, the second one, a to the m divided by a to the n. So 3 to the 4 divided by 3 to the 3, for example, would be 3 times 3 times 3 times 3 over 3 times 3 times 3. Incidentally, you don't need to necessarily write all this down because you can see it on the video, and I'm only explaining what you really need to remember, which is the laws of indices. So, don't worry too much about writing all this down. If we write that, you can see that we can cancel. 3 goes into 3 at the bottom and 3 at the top. 3 goes into 3 once, 3 goes into 3 once. I can do that again for this and again for this. So we end up with this equal to 3. 1 times 1 times 1 times 3 is 3 on the top and 1 underneath. So we end up with just 3. And that is 3 to the power 1. So if there is no power, it means power 1. How do we get to that? We subtract the powers. 4 take away 3 is 1. So the second law of indices says a to the m divided by a to the n is a to the m minus n. They are the two basic laws of indices outlined here. A to the m times a to the n is a to the m plus n. Add the powers, divide, subtract the powers. Remember that. You've got it written down, but you should remember it. If the base is the same and I multiply the two numbers together, what do I do with the power? Lewis. Yeah. Right. If the base is the same and I divide, what do I do with the powers? Matthew. If the base is the same and I divide the numbers, what do I do with the powers? Minus them, subtract. I subtract the bottom one from the top one. N. So it's the m minus the n, or you subtract the bottom one from the top one. These other 4 come from those 2 laws of indices. So these first 2, we can see how they arrived at, and there's an implication about these that means we can write down 4 more laws, but we can derive them directly from the first 2. Let's have a look and see how that works. If I look at the third one, and I'll take an example, 3 to the power 4 squared, for example, then from the first laws of indices, and what we know by squaring, that means a number times by itself, that's 3 to the 4 times 3 to the 4. That's what squared means. And now I use the first law of indices. What do I do with the powers? So I get 3 to the 8. And effectively what we do is we multiply. If I've got a base raised to a power and then that's all raised to another power, I actually multiply the powers. So I get the third law of indices, which says that a to the m, like 3 to the power 4, all raised to another power, n, becomes a to the m times n, or mn. And that's the third law of indices. But it comes from the first one, really, if you think about it. So that's the third law of indices, and those are the 3 really main ones. And then we come to some interesting ones. 4 and 5 are actually really quite important when it comes to calculus. So I want to just dwell on these for a little while. The logic around number 4 is a bit tortuous, so let's look at it. By way of example, okay? Answer, maybe tell me? 9. The square root of 9 is 3. Multiply that by itself and I get 9. The square root of a number is a number which, when multiplied by itself, gives that number. The square root of 9 multiplied by the square root of 9 gives 9. That's the definition of the square root in a way. But if I think of this in terms of the laws of indices, 9, base 9 multiplied by something else to the base 9 gives me 9 to the power 1, which is what 9 is. What must these numbers be? The powers to give, when I add them together, 1 must be a half. A half plus a half is 1. So another way of writing the square root of 9 is 9 to the power of half. What's the cube root of 27? Anybody tell me? Sorry? 3. Times it by itself 3 times, what do I get? 27. So in other words, the cube root of something, by definition, is a number which, if I multiply it by itself 3 times, gives that number. The cube root of 27 multiplied by itself 3 times gives 27. That's what we mean by the cube root. Thinking of it in terms of the laws of indices, I've got to end up with 27 to the power 1, because that's what 27 is. So this, which is 3, 27 rather, base 27, base 27, what fraction, if I add it to itself 3 times, gives me 1? A third. So in other words, the cube root is the fraction a third. The root is the number underneath in the fraction, because of this sort of logic. And in a way, it doesn't matter what this is. 27 is 3 cubed, so I could have a number inside this root that's squared or cubed or to the power 4. That would stay the same, and that would go on top of the fraction. So we end up with something like, for example, the square root of 5 cubed multiplied by the square root of 5 cubed gives 5 cubed, by definition of the square root. So this could be rewritten as 5 to the 3 times a half, or 3 over 2. So I can write this as 5 to the 3 over 2. And that's what the fourth laws of indices tells us. It tells us that the nth root of a to the n can be written as a to the n over m. And that's what you need to be able to use and remember. So using this rule, the fourth root of x to the 5 would be written as right, x to the 5 over 4. Okay? Sadika, you happy with these? Okay. Robert? Right. This fraction, if you're in doubt about which way around the fraction goes, one little way to try and remember it is to say the root, which is in this case the fourth root, goes underneath, because roots go underneath the ground, so go underneath in the fraction. Okay? It's a way of remembering. How can I rewrite the fourth root of x to the 5 as x to the 5 over 4? And any of you that have done calculus will know that to differentiate something like this, you have to rewrite it like that before you can differentiate it. So you need to know this law of indices to be able to do it. So that's the fourth law of indices, and it's to do with roots. And it introduces the fraction as a power. So we can have a fraction as a power, and the denominator in the fraction tells me what root I've got. Lastly, I've got the sixth law of indices. If we go to, sorry, the fifth law, not lastly, the fifth one. This one, a to the minus n equals 1 over a to the n. Let's look at that. So the fifth law again, let's look at it by way of example. If I've got 4 to the power 3 and I divide that by 4 to the power 5, using the laws of indices, how can I rewrite this as? What can I rewrite it as? It certainly is, because it's the top one minus the bottom one. 3 minus 5 is minus 2. Thank you. Okay. But if we now think of what 4 cubed is, in terms of numbers, like we did before, 4 times 4 times 4, over 5 of these things, you can see, as we did before, I hope, that I can cancel out 4s into 4 top and bottom, 4s into 4 top and bottom, and so on. So I can cancel out 3 of the 4s on the top with 3 of the 4s on the bottom, which leaves me 1 over 4 times 4, or 4 squared. So in other words, 1 over 4 squared is the same as 4 to the minus 2. And a minus sign means the inverse. This is the inverse. 1 over is the inverse. So the inverse of 1 over something is written as a negative power. Underline the negative. An inverse is written as a negative power. For example, the inverse of 3 to the power 4 can be written as 3 to the minus 4. Minus means the inverse. One over x to the power 5 can be written as x to the minus 5. Minus means the inverse. 1 over the square root of x can be written as x to the half, because the square root is a half. Remember, there's no power on x, it's x to the 1. There's no number inside the root, it's the square root, so a half. The inverse can be rewritten as a negative power, so finally I can rewrite that as x to the negative a half. They're all the same way of writing the same thing. You might need to see it written like this, and certainly if you're going to try and do calculus with this thing, that's how you'd write it. You might want to see it written like that, and you might want to see it written like that. You need to recognize that all three things are 3 different ways of saying the same thing. Negative means the inverse. There's one more to look at, and I'm going to leave you to try and prove this one for me. Anything to the power 0 is 1, is what this last one is saying. A to the 0 is 1. A can be anything. So any number, not anything, any number. So any number raised to the power 0 is always 1. And if I leave you, you could try and show why that's true. Thinking about the same sort of things as I've been doing here, look. Thinking about what we mean by 3 to the 4, what does it mean? I'm sure you can prove that for yourselves. So the last law of indices, you can prove for yourselves. There are 6 of them altogether. And you need to remember what they are. You don't need to go through the derivation, as I've just done, but you need to be able to use them. These 2 that I've asterisked here particularly are the ones that are worth getting to know.